And now we got to go over how to calculate weight. Last video was calculating density and figuring out which objects sink and float. Now we need to go over or calculating metric weight, and then what weight is actually a measurement of in the metric system. So in the last video I went over force. If you didn't watch it, I'm going to review it real quick. If you understand how force works and vectors work, you can probably skip this video. But for those of you who don't know or need a review, I'm going to do that right here. So in order to calculate weight in the metric system, and weight is all dependent on gravity. Depending on where you are, something is going to weigh a different weight. Like on the moon, this is going to weigh less than it does here on Earth because the gravity is different. So in order to calculate metric weight, you need the force equation. So force, and for this one we're going to put W for weight, equals mass times acceleration. Okay, so the force, the weight, now this is the tricky part. Mass has to be measured in kilograms in this equation. Okay, so why is that tricky? Well, because triple beam balance is always measured in grams. So we're going to have to do some conversions. Okay, so I have my kitchen scale here again, and I'm going to calculate, or I'm going to weigh it in grams, and it's 14 grams. So down here, I'll go over this real quick. You should be able to do this in your head, but you know, it's been a while. So 14 grams equals how many kilograms? And if you use your metric ladder, that should be in the front or back of your notebook. To get from grams to kilograms, we're going to move it 3 places to the left. 1, 2, 3. And I'm not going to do this each time. Hopefully you know how to convert units. So 0.014 kilograms. So my bolt has a mass of 0.014 kilograms. Okay, so the acceleration versus gravity doesn't change. Okay, so it's 9.8. And if you don't know how all this works, you can look at my Bernoulli's principle video before this one. Okay, so I have my 0.014 times 9.8. 0.14 is good enough. 0.14 kilogram meters per second squared. Okay, and then this unit, like it says in the other video, is going to be 0.14 newtons. Okay, so I have a weight of the bolt of 0.14 newtons. Okay, and that's how to calculate that. In fact, I'm going to write that down. I'm going to scratch a piece of paper over here so I don't forget. 0.14 newtons. Okay, and I'll do the woodblock too. So that's the bolt. So the woodblock is exactly the same thing, except the mass is obviously going to be different. So force, weight equals the mass in kilograms of the woodblock times the acceleration versus gravity. Okay, so the mass of the woodblock, 13. So 13 grams is going to be 0.013 kilograms. And you got to move the decimal 3 places to the left. So I'm going to say, I'm just going to put that 0.013 kilograms, running out of room, times 9.8 meters per second squared. Go ahead and calculate that. 1.34 newtons. Okay, now I want you to look at this real quick. The force, or the weight, of the bolt was 0.14 newtons. Okay, the weight of the block is 1.34 newtons. But wait a minute. If that's true, if the wood block weighs more than the bolt, why does the bolt sink but the wood float? And again, that's what I'm going over in these few videos, is what's called Archimedes principle. Archimedes was the one that figured out all this stuff. So that's how to calculate weight. So one thing you're going to need to know, 8th graders should already know this, but if I have my bolt, here's my bolt. Okay, this is how to use vectors briefly. I have a force pushing down of 0.14 newtons. Okay, and because the bolt is not moving in any direction, that means the floor is pushing up with 0.14 newtons as well. The forces are balanced. Okay, so I've got a force pushing down and I've got a force pushing up. Okay, I don't know if you've ever heard the for every action there's an equal and opposite reaction, but yeah, the floor is pushing up with the same force that the bolt is pushing down. Okay, so for the wood block, it was 1.34, so 1.34 newtons. The floor is pushing up with 1.34 newtons. So there's two motions, there's two forces going on here, not just one. Okay, so that's how you calculate weight, and that's how you do what's called a force diagram using vectors. Okay, that's it. Hopefully I see you in part 3, where I explain the major thing, which is Archimedes' principle, putting all this stuff together. Okay, hope to see you in video 3.